Hello everyone, myself Hitesh and I am currently pursuing my BE in cybersecurity at Sri Venkateswara College of Engineering. Today's presentation is about C programming. Introduction to C. C is a powerful and versatile programming language that has been cornerstone of a computer science for decades. Developed in 1970s by Dunstan at Bell's Lab, C was initially created to write a Unix operating system. Since it has evolved into a widely used language that has foundation for programming language and has application in wide range of fields, from embedded systems and operating systems to game development and scientific computing. At its core, C is low-level language that provides direct access to compute memory and hardware. This makes the excellent choice for building efficient and performance critical software, as well as working with system level programming tasks. C simplicity and flexibility have also made it popular choice for teaching programming concepts, and it's often the first language learned by computer science students. History and development of C. It is of three types. Origin. C was developed in early 1970s by Denny at Bell's Lab. Research and development arm of AT&T Research or created C as a way to write a Unix operating system, which was being developed at Bell's Lab. Second, standardization in 1978. The first edition of C programming language by Brain and Denny was published, establishing the language syntax and semantics. This book became the de facto of standards C programming and helped popularizing this language. Next, throughout the 1980s and 1990s, C gained wide popularity and became a fundamental language for a wide range of applications for system programming to game development. Its portability and efficient made it popular choice for developers working on a variety of platform and hardware. Basic syntax and structure. Syntax. C has a relatively simple and straightforward syntax with a focus on using keywords, function, and variable to build program. The language uses a set of reserved keywords such as int, for, and return to a defined program structure and control flow. Programs in C are typically organized into one or more source file, each containing a series of statements and functions. These files are compiled into a machine-readable code that can be executed by a computer. Structure. The basic structure of C program includes a main function which serves as an entry point for the program. Within a main function, developers can define and call additional function, define variables and write statement to perform various operations. C also supports users for processing directors, which allows developers to include external code, define and customize the complication process. Comments. C allows developers to include comments in their code, which are ignored by a compiler but can be used to provide explanation instructions or notes about the program functionality. Single line comments are denoted by the double slash symbol, while multiple comments are enclosed within slash and data types and variables. Primitive data types. C supports a variety of primitive data types including integers, example int, short, long, floating point numbers, example float, double, etc., characters, and Boolean values. Developers can use these data types to represent a different kind of data in their program. Variable declaration. Variable in C are used to store data value during program execution. Variables are declared using a data type and unique identifier and can be initialized within a value at a time of declaration. Type of modifiers. C also provides type modifiers such as signed, unsigned, constant, and volatile. that can be used for further refine the property and behavior of a data type and variables. Next, dynamic memory allocation. In the addition of static variable declaration, C also supports dynamic memory allocation using function of malloc and calloc, which develops to allocate and manage memory. Operators and expressions. Arithmetic operators. C provides a range of arithmetic operators such as addition, subtraction, multiplication, division, and modulus that can be used to perform mathematical operation and variables and values. Relational operators. Relational operators such as equal to, not equal to, greater than and lesser than, greater than or equal to and lesser than or equal to are used to compare values to make decision in C program. Logical operators. Logical operators including and, or, not can be used to combine and manipulate Boolean expression in C. These operators are often used in controlling structures such as if-else statements and loops. Bitwise operators. C also supports bitwise operators such as AND, or XOR, NOT, let shift, and right shift, which allows developers to perform low-level operation on individual bits of data. Control structures. It is of three types. 1. Conditional statements. 2. Loops. 3. Branching and jumps. 1. Controlling statements. C provides a conditional statement such as if else switch case construction that allow developers to control the flow of their programming based on their certain condition or values. Loops. Second, loops. Loops including the for loops including for while and do while loops enable developers to repeatedly execute a block of code until specific condition is met. Loops are often used for tasks like iterating over array, processing data, and implementing algorithms. 3. Branching and jumping. C supports branching and jumping statements such as break, continue, and go to, which provide additional control to the program's flow of execution. This statement can be used to skip iteration, exit loops, and jump from specific location to code. Function and pointers. Function in C are self-contained blocks of a code that can be called from other part of program. They allow developers to encapsulate and reuse common tasks, improving code organization and mainability. Function can accept input parameters, perform operation, and return C and return the program. Pointers. Pointers are the powerful features of C that allow developers to work directly with the computer memory. Pointers are variables that store memory addresses which can be used to access and manipulate data stored in this location. Pointers are often used to dynamic memory allocation, passing large data structure and data structure to function and implementing low-level data structure. And C provides a variety of algorithms. Array and strings. C supports the use of array, which are collection of variables and some data. Some data types. Array can be used to store and manipulate large amount of data, and they are or often used in conjunction with pointers to access and process array elements directly. C also provides built-in supports for string, which are array of characters. Strings can be manipulated using variety of strings related function and libraries such as standard C string library. Input, output, and file handling. Console, file handling, network, error handling are these types. Console. C provides standard input and output functions such as printf and scanf, which allows developers to read data from the console and write data to the console respectively. These functions are part of standard C library and widely used in the basic input and output operation. File handling. C also support file-based input and output operation, allowing developers to read from and write to a file on the file system. Functions like fread, fopen, fwrite, and fclose are used to open, read, write, close, and file respectively, enabling more advanced data storage and capabilities. Network. In addition of console and file based, C also provides supporting for network based input and output operating, allowing developers to create network enabled applications and service function like socket, connect, send, and receive are used for low level network programming or in C. Error handling. C provides various mechanisms for error handling such as return value and error value, which allow developers to detect and respond to the errors that may occur during input or output operations. Proper error handling is crucial for building a robust and reliable application. Conclusion. C is a powerful and versatile programming language that has stood the test of time, remaining a fundamental tool in a world of computer science and software development. Its low-level access to hardware combined with simplicity and efficiency make it an excellent choice for a wide range of applications, from system programming to game development. A technology contains to evolve C's fundamental role in computer science ensure that it will be remain a valuable relevant language for years to come. Mastering C is not only provides strong understanding of programming fundamentals but also opens door to deeper exploration of computer architect, operating system and other essential areas of computer science. Whether you are second sense with programming or just starting a journey in the world of coding, learning C is a sense and experiencing that serve well throughout a career. With this history, powerful features, and enduring relevance, C remains in a cornerstone of programming world and poised to continue shaping the future of technology.